So again, we are moving on with fractional operations. Today we are talking about dividing fractions and mixed numbers and whole numbers together. Any questions? The first thing we're going to do is review how multiplication and division can create a fact family because they are opposites of each other. They are inverse operations. So in order to review what a fact family is, I'm going to do an example with adding and subtracting because those are also opposite and inverse operations. So I can say 1 plus 3 equals 4. 3 plus 1 equals 4. 4 minus 1 equals 3. And 4 minus 3 equals 1. What makes them a family is that every problem has the same 3 numbers, just using inverse operations. Does that make sense? What? Quickly. All right, so I want you to do the same thing, but using multiplication and division by looking at the two models. You are writing a multiplication and division fact family for each model. Any questions? All right, I'm giving you 4 minutes. Yes, one of the multiplication problems represented in this model is 3 times 6 equals 18. So what is another multiplication problem represented in this model, Davian? 6 times 3 equals 18. Who can tell me one of the division facts?
18 divided by 3 equals 6.
18 divided by 3 equals 6. And another division fact.
18 divided by 6 equals.
Any questions about the fact family? What do they all have in common? 3, 6, and 18. Yes?
Yes.
All right, what about number 2? 2 times 7 equals 14. Another multiplication problem. 7 times 2 equals 14. Ryland, division. And somebody on this side. 14 divided, that's what we have. Tell me the other one. There we go. What do all these have in common? 14, 7, and 2. It doesn't change if they're a fact family. They all have the same 3 numbers. Please put your chair down. Thank you. We had one fall and bumped her head the other day. We want to make sure you're safe.
Did you wake up in the morning? Did you wake up in the morning?
Go ahead and turn to the next page. Okay, we're going to take a little bit of time on this because we want to help you conceptually understand what's happening before we get to the algorithm to do the actual math. Okay? So I will apologize up front. This part is a little bit hard, but once you actually get to start seeing it, it will start to make more sense. So last time I just started with what they've given us, and it caused a lot of confusion. So let me start with an example I like to use on this first, okay? So if I'm going to model something, who can tell me what that would be modeled as mathematically? 2. So that's 2. Now, what is the math term if I cut something, numbers into something? Yeah. Yeah. What's the math term? What operation am I doing if I cut them into pieces? So I'm going to divide these into 4. Okay? So each of these 2, I'm going to cut them into 4. Does everybody agree that my 2 have now been cut into 4s? So mathematically, what number would I write that I just cut them into? 4. Okay? So I took the 2, I divided them into 4s. Now, can someone count how many pieces do I now have? Okay? So conceptually, does this make sense?
No. Yeah.
Can you see it? So I started with 2. I cut them into 4s. I now have 8 pieces.
4 plus 4 equals 8. You should learn this like fractions.
Okay? That is why this is tough.
Yeah.
DJ just brought up last class, what did we do? We multiplied by fractions, and my numbers got smaller. And that was tough because normally when we multiply, it gets bigger, right? Well, division, we have that same issue when it comes to fractions. If I divide 24 by 6, what do I get? 4. It gets smaller. But when I take my 2 and I divide it into 4s, what do I get? 8. It gets bigger. Here's why it's tough, guys. What we're doing when I'm dividing by fractions is I'm cutting those holes into little pieces. And I'm saying, how many little pieces do I now get out of those 2 holes? So if I think about it that way, does it start to make more sense? Okay? So we just did fact families. That should help us on this next part. So if I consider the unit square model divided into 5 equal rows and 4 equal columns. Okay? The shaded block right here. Everybody see that shaded block?
Yep.
Okay? So if I wrote that as a number, I've now taken my one whole unit, I've divided it into 5 this way, and I've divided it into 4 this way, correct? Everybody good with that? Okay? So my shaded area is now how many is in shade? 1 out of how many boxes do I now have inside of my rectangle? 20. Does that make sense? But everybody see that that is 120.
Yeah.
Everybody's good on that, right?
Yeah.
Okay. Now here's where this gets a little interesting. So the height of the shaded rectangle is 1/5 of the height of the model. So my height has been broken into 1/5. So you can see that we have 5 of them, correct?
Yes.
Is everybody okay with that?
Yeah.
My width is 1/4 of the width. We see that that width has been broken into 1/4. Everybody okay with that?
Yeah.
So if we go back to the area model, we did our first full lesson, basic, without leaving chairs. If we go back to that first lesson, we can now see my fact family. If I do 1/5, and I divide it and try this way, times 1/4 going this way, this is the model we just did last class, right? The only difference is instead of showing that whole 4th this way and that whole 5th this way, they only just focused on the one that's the same. So this is what we did last time, and this one box is the only one that would have had colors from both colors. So is everybody okay? So that's the 1/5 times 1/4 equals 20.
Yeah.
So there's your baseline for your fact family. We just worked on fact families in our opening exercise. So now I want a multiplication division fact family for the model. I'll give you a hint. Your first sentence is 1/5 times 1/4 equals 1/20. See if you can do the other 3. I'll give you guys 1 minute. Go. Guys, the next one is easy because all I need to do is change my multiplication term, right? 1/4 times 1/5 equals 1/20. And then to do division, all I'm doing is I'm taking the product and I'm making it the dividend. So it's 1/20 divided by 1/4 is 1/5. 1/20 divided by 1/5 is 1/4. So you have 4 different multiplication division fact families. Got any questions on those?
Wait, are we supposed to do the next 2 questions?
If you did number 2, that's great too.
Well, I thought you said the last one.
That's what I said, it's doing your fact families. We do need our highlighters / colored pencils, markers, whatever you're doing to highlight your text. We have another math term over here. Okay, our math term says, guys, write it down. A positive rational number. It's actually really key, and this is often one of the biggest differences between 6th grade and 7th and 8th grade math. We are going to be working mostly all year with positive rational numbers. You know it's a positive rational number because you can write it in the form of fraction, A over B, where A and B are both whole numbers that are greater than 0. So we will be doing almost all of our work this year in positive rational numbers. The nice thing is you don't have to worry about all the other rules that come along once we start working in the other number. So if we look at this, can you describe how the model shows the division of fractions? Anybody want to take a shot? I don't blame you. Oh, okay. That's it. Good. So you just said, well, if we just look at it the other way, look at it. Take my 1/20th, that's that whole. Does everybody see that? And I divide it by the 1/4. So 1/4. So I would have colored this 1 out of the 20 for my original, right? Then I'd do the 1/4. So I would have colored that. Then for my second color, to show that I'm dividing it into 1/4, I would have come across this way, right? So if I look at that, how many of the boxes are still colored? 1. But now because I went this way to show what I was dividing, I have to go this way to show what it was. Well, how much was it? 1 out of
1 out of 5.
5. 1/20 was the whole thing. That's what I divided up, right?
Yes.
I divided it into 1/4. So I cut it all the way across. What I ended up with is this 1 colored out of the 5 in this row. So there's where our division model shows this. I'll be honest, guys, if you don't see it, don't stress. This is high concept level, just to help you see what's happening. Unfortunately, we don't get to the algorithm until next class. Mostly modeling today, but this will get us on the track to be able to do this. Okay, we're actually going to skip this because Mr. Sham put it out of order. Not that I'm throwing it under the bus on YouTube or anything. Oh, maybe I did. Darn, sorry about that.
Let me believe what I think you want to.
Okay, division is the process of breaking a number up into equal number of parts. So this is where the division gets a little funky if you don't think about what we're doing. So here, the model says, if I have 6, but I'm going to divide it into groups of 2, the question that the division problem is asking you is, how many groups of 2 are in 6? So if I take my 6 and I start breaking it into groups of 2, how many groups of 2 are there in 6? 3. So 6 divided by 2 equals 3. Does that make sense for everybody? I'm getting a little worried about you. I don't know what's going on underneath your desk, but we need to stay on top of the desk. You don't need your computer. Good. Okay. So is everybody okay with this model and what our result was? Everybody understand it? Okay, so now here's where it gets conceptually a little more difficult. Because now I'm going to take 6, group of 6, same group I started with, right? But instead of breaking it into groups of 2, I'm breaking it into groups of 1/2. Okay? So what that means is, for every whole, I'm actually getting 2 groups out of it. Because there's 2 1/2 and 1 whole. So everybody okay with that? But I'm doing that 6 times. So I now have 5, 6, 7, 8, 9, 10, 11, 12 groups. Does that make sense?
Yeah.
If I were to rewrite that, again, the way we talk about division problems is we say, how many halves or groups of 1/2 are in 6? The answer is 12. There are 12 half parts in 6, which really makes sense if I'm dividing each one into 2 boxes. I now have 12 boxes when I get done. Is everybody okay with that? Okay, so here's the key. We need to identify the dividend, the divisor, and the quotient in each model. So in our first one, 6 we divided into 2. I've got a group of 3 groups of 2, correct? What is my dividend? In other words, what number am I breaking up? 6. So my 6 is my dividend. Write that right in your book. My divisor is telling me what's the size of the groups that I'm breaking into, right? So I took my 6. What size was the group that I broke it into? 2. So my 2 is my divisor. And the 3 is the answer to the question. How many groups of 2 are there in 6? In this case, it was 3. So that is my quotient. Is everybody okay with those math terms?
Yeah.
Okay, let's try it on our second model. Second model, what was it we broke up? In other words, what was my dividend? Okay. 6 is still my dividend, right? What was my divisor? How much did I break it up into? 1/2. So my divisor is 1/2. And my quotient, how many groups of 1/2 are there in 6? For an answer of 12. My 12 is my quotient. Okay, so let's pull out your highlighters again, because they actually have defined all of these over here, just to make sure everybody understands what we're talking about. The dividend is the number divided into equal groups. In other words, and this is actually the first thing you need to ask yourself, especially on these word problems. The first question you should ask yourself is, what am I splitting up? That has to come first. That's my dividend. That's what's getting divided. Okay? Your second question is, how many groups am I breaking it into? What's the size? The divisor is the number that divides the dividend. Saying how much is in each one of those groups. And then your quotient, the last part, is the result of the division. In other words, how many groups of my divisor are there in my dividend? Because as we're talking about division fraction division, that's really that key concept, that key question that you need to be able to answer at the end of the day. Any questions on this first page? Okay, guys, I'll be honest, your math terminology is really important, because if you can understand those 3 pieces, it's going to make the rest of this a lot easier. Okay, so let's go to our next page. So we're on page 47. I didn't do this one. We skipped page back, right? Oh, that's actually page 51. Never mind. Mr. Sham really had fun with this lesson. Let's go to page 48. This time is really put the lessons together. Yeah. Right. Here's what we're going to do now. And this is actually real life for us, because we've done field days. Hopefully we're getting back to the point where we can. So we're organizing games for a field day event that lasts for 4 hours. Guys, did anybody see what I just did? It's called marking my test. You all should be doing it. I see a whole lot of not pencil moving, Dominic. You guys should get used to marking your tests and help you break these problems down. 48. We skipped. We skipped up to 48. I put organizing, but it really could be the one. Okay. So our first step, determine how many games you can organize for the event if each game lasts a given amount of time. Draw a diagram and write the appropriate number set. So we got 3 things we're doing, right? I want to figure out how many games I can do. I need to draw a diagram that gave me a baseline, so that's nice. They gave me the model to start from. Then I'm going to write the appropriate number set. I'm going to do number 1 to model this for you. Okay? So on number 1, I'll give you a big hint. Your denominator is telling you how much I'm cutting each part into. So each group is being cut into thirds. Okay? So I'm doing groups of 3. So that's the first thing I want to do in my model. To say, how am I cutting it up? So I'm cutting it up into thirds. The second thing I want to do, and here's where you can use a highlighter or another color, is my numerator is showing me how many are in each group. So each group has 2 of those thirds in it. Make sense? So I'm going to shade 2. So that would be 1 whole, right? I've got 1 whole 2/3 at that point. I would then use a different color. So there's a second group. Then you can go back or use a different one. There's a third group. I'll switch to the pen because that's not working out well. So there's 4, that was 3, that was 2, that was 1. We're then up to 5. And finally, 6. So how many groups of 2/3 did we have in 4 hours? 6. So now, did I determine how many games I could do? So you do 6 games. Should I draw a diagram?
Yep.
Yep, my diagram's all shaded. Write the number set.
Yep.
Okay? So, again, when I'm doing a division problem, remember, we don't have a commutative property of division. My order matters. So I have to be very clear. What am I cutting up? Am I cutting up the 4-hour block or the 2/3 hour?
2/3 hours.
No, I'm cutting up the 4-hour block. Okay? How am I dividing that 4-hour block? Into 2/3. And what did it equal? 6. So I now have my number set. Yeah. So this is my answer. That determines how many. This was my model. So that was the diagram. This is the number set. Okay? Need to number it. That was 1. That was 2. And that was 3. So each one of these questions has 3 parts to it. You only have 2 more problems to do. If you finish that, you can start to think about part B. We didn't really do question 2, but start thinking about what it is, okay? And we actually did do the 1-6 piece. You can see it. Yes, they do. No, because then I can't see what it's writing. That's right. You should be okay. Okay, you guys will give you about 6 minutes to do these 2 problems. You may work together with the table if you need to, and there's a chance back there if you need extra help. You go back to the table. Okay, so let's take a look at it. On our first one, again, my denominator is showing me how much I'm dividing each block into. So this one, what? Dang, don't mess up the recording. Okay, so the first one, I'm turning into fifths. So 1, 2, 3, 4, and then that fifth is that next mark. So I'm doing this for each one of them, and every block is being divided into fifths. So because of my numerator, that's telling me how many of those blocks make one whole grouping. So I'm breaking it into 2 fifths. Does that make sense for everybody? Okay, so that means first one, that's 1. Actually, it's easier to go back. So that's 1. My second group, there is 2. My third group of 2 makes it 3. My fourth group makes it 4. My fifth group of 2 makes us at 6 or 5. My next one, there's 2 more. That puts us at 6. My next one puts us at 7. My next one puts us at 8. Next one puts us at 9. And our last one, if that came out evenly, that puts us at 10. So you can do how many games?
Yes.
10 games. And my word sentence, number sentence is 4 divided into 2/5 equals 10. Okay? Our next one, we're actually dividing it the same way. We're dividing it in fifths, right? Evan, what are you doing? Let's not do that. You should be focused on what's happening. So we're doing that same deal. I'm still cutting it into fifths. But now, how many makes one group? 4 of them. So now, as I'm looking at my groups, I need 4 in order to make one whole group. Then I do another 4 for my second group. Then I do another 4 for my third group. My next 4 gets me to my fourth group. Oh, did I mess it up? I did. That one should go to here. It goes here instead of there. That one's too much. Okay? So that was our fourth group. And then our fifth group actually starts here. So how many did we end up with? 5. So you can do 5 games. What is our math sentence? It's 4 divided into 4/5 equals 5. Is it starting? Are you going to start to see how this all comes together?
Yes.
Zoe, which part's messing you up? Which part's messing you up?
Yeah, I got 24.
Okay. Okay, the problem, I can tell you right now, the problem was, no, I can't. Did you divide it into groups of 6?
Yes.
Okay. So the problem was you divided it into too many groups. I was supposed to do groups of 6. And then instead of counting every 2, you counted every single one. So you did 4 divided by 1/6. That's how you got 24. So you have to pay attention to both the numerator and denominator. They're both giving you pieces of information you need. Okay, good. The big key on this, and actually let's just go ahead and add this here. We didn't do this with our first period. So for the dividend, for the divisor, if the fraction is in your divisor, the denominator tells you how many each block is being split into. In other words, how many pieces am I making? My numerator is telling me how many make a group. Okay? So you broke it into fifths like you were supposed to, but you again only did 1 instead of 4. You broke part C, you broke it correctly. You broke it into fifths, but you were counting 1 of those 20ths as a whole, when it was supposed to be 4 of them. Okay? So your numerator is telling me how many I need to count in order to get a whole group. That's why we were doing groups of 4 here, but only doing groups of 2 here to count it as 1. Because that's our difference in the numerator. My numerator here was 2, so every 2 made a group. Here my numerator was 4, so every 4 made a group. Does that starting to make sense? Seeing it? What? That's fine. Which part don't you get? A, B, or C? C. Okay, which part of C don't you get? The 4? So it said, break it into groups of 5. We had to break all of the 4 into groups of 5. Make sense? Well, then it says to count for one group, I need 4 of them. So of the 5 the lines that I made of every 5, every time I got to 4 of them, that was a group. So there was one group, 1, 2, 3, 4. There was a second group, 1, 2, 3, 4. There was a third group. I just colored that one wrong. 1, 2, 3, 4. That gave me my 4th group, which left me with 4 left. Everybody okay on this so far?
Yeah. No.
Okay. Don't worry if you're not. I'll give you some more practice. Okay. On this next part, we're going to look at the relations between the different division statements that we just modeled. So the quotient of 4 divided by 1/3, the quotient of 4 divided by 2/3. So that actually goes back to the model that we had. Okay. So we did, what did we do 1/3? Oh, that was the one Mr. Shan erased. Nothing, don't worry about it. Okay. So we can use this model to talk about it, all right? So this one we did into 2/3, and we ended up with how many groups? 6. Had I done it into 1/3, so now I'm counting every single one, how many would I have had? I'd have had 3 for every 4, right? So I would have had 12. Okay? So when we look at that, let's go back here. So 4 divided by 1/3, that one equals 12. 4 divided by 2/3 equals 6. Does that make sense for everybody? Sorry? I'm sorry? We're past that one for now. You missed an important note though, so I would go back to the video and watch it, but I can't spend that time now. So we have 4 divided by 1/3 is 12. 4 divided by 2/3 is 6. Anybody see a linkage there? What's the linkage? DJ?
That is 2 times greater than
Good. So, because 2, it took 2 for every third to get 6. So when I counted it as 1 for every third, it was 12. So when I divided this by 2, I multiplied this by 2. Okay? Because it took 2 of those 1/3 groups to make 1/3, 2/3 group, right? Does that make sense for everybody? Okay? So it took 2 of each 1/3 group to make 1 group of 2/3. That makes sense for everyone. So I do 2 of those 1/3 groups, I get a group of 2/3. Well, dividing by 2/3, it's going to be half of the number of groups. It takes 2 of all of them just to make 1 of group. So if I think about that conceptually, so I now know 6 divided by 1/2 is 12. That's all the initial model that we used. Everybody good with that? So I took those 6, I divided each of them into halves, gave me 12. Now think about it. What if I divide them into 4, into 8, into 16? Can you figure out what my quotient is for each of those? So you've got 3 problems to do. I'll give you guys about 3 minutes to talk about it as a group. See if you can come to a conclusion as to how to figure those out. Right? Why can you do that? So I'll just run through this real quick for those on the recording. Counted up how many groups of 3 we ended up. We said there were 2 parts left over out of 5 in the block. So there are 6 and 2/5 servings. You're going to look at the numerator instead of the denominator for the remainder. Okay, guys, is this making sense to you? So I have good news and bad news.
What?
Be quiet. So your good news is, next class we're going to go to the algorithm instead of all the models. But you need to understand how to model it. The good news is, homework tonight is